Alright, so welcome to everyone. This is Maths is a Game. We are doing grade 11, pure maths. Um, Unfortunately, maths lit is not an area that I focus on, but I'm sure there are more worthy suitors that can focus on that area, which will probably do a good job in that section. Right. So for grade 11, last night we looked at how to complete the square of an expression, and then how to find the maximum or the minimum value of a quadratic expression. And then we also looked at how do we identify the value of x, which gives us a maximum or minimum. And we basically, left each other having said that there are exercises that we can do, which we can then be able to check ourselves personally if we are actually getting this concept of completing the square of a quadratic expression. Alright, so before I transition into the next topic, I will firstly just review some of the homework, or let me say game challenge problems I had sent, just as a way of sort of like reminding us what we did yesterday. So I'll just take two of the problems the game challenge problems that I sent yesterday, and which I had asked people to go ahead and at home and do. And then what I will do is then after that, I will then get into what we are going to look at for today. Right. So yeah, hopefully the session will be fruitful and it will be beneficial to all. Hello Nuri, it's nice to see you in the live. And please, people, I just want to apologize from the onset. I do have little bambinos that basically make this home a very pleasant place to be in. And so if you hear an occasional scream or an occasional shout or whatever, then basically just know that it's one of them. Mfana Nkosi, you are welcome as well. If you can just channel that energy that you have in the direction that it's currently going, redirect it and make it positive. Maybe you will leave comments that will uplift those who are actually trying to get started with their maths syllabus early. And then you can leave us in a positive spirit rather than leaving us with this negativity that it seems I can feel in the air because of your comments. But I feel you're a good man, but just understand the situation that we are in, and then leave us with positive comments accordingly. I think Mfanangos, I'm going to actually read you of the situation that you find yourself in, because I sense that make sure that they confirm as to whether my network is networking or not. So I want so far for you to comment for me and just let me know if the network is networking. Can you guys see? Can you see and can you hear? Am I audible enough? I just changed my network connection from something else to another, because usually when I connect to my Wi-Fi, I don't know if it's because this thing starts with a W-I-F-E-I, Wi-Fi, but it gives me problems, So as a result, I have to change to my actual data, which is, you know how it is now in this time of the month. Educators Yeah, hey, the data, guys, it's not dataring. But anyways, so yesterday we looked at completing the square of an expression. So I'm just going to take square of an expression. And guys, if you want to basically go into the concept behind this thing, please go onto my YouTube channel, Maths is a Game. You can watch the entire session that I covered yesterday and take it one step at a time. Yeah, hopefully that can assist and help you. Yeah, if I can just have people on the ground. You see now it's saying unstable network from my side. Now I'm wondering if it's affecting everything and everyone else. Okay. All right. Okay. So let's look at, like I said, let's look at a few problems. Hello, Simplicity. Okay, it's fine. It's your network, sir. So it is my network. So my network is not good then. My network is doing funky stuff. It's doing somersaults. Hey. Okay, from Aviwe Quarter's side, it's fine. And Yuri says it's my network. Musa Changa says it's fine. I just need to get other confirmations. Okay, Lotleho also says it's fine. Okay, so we'll just roll with it then. I think from what I'm seeing now, it's stable. Thank you very much. It's actually on my side, it's also green. So it's all good. Okay. Now, let's look at a few of the homework game challenge examples I gave you, just so that we can confirm. The YouTube name is Maths is a Game, just like the TikTok page. It's Maths is a Game, 527. The link is in my bio, the YouTube link. You can go on there and you can find the YouTube link for the page. All right, so let's look at this expression. Let's look at a few. Let's first start where there's a positive coefficient. So let's look at 2x squared plus 5x minus 1. Let's look at this one. How do we complete the square of the expression? First and foremost, I'm sure from yesterday, remember that we want to change this quadratic expression, because this is an expression, okay? We want to convert this quadratic expression into the turning point form of its form. So basically what we do is we need to first make sure that the coefficient of x squared is 1, all right? And remember, this is an expression. In order to ensure that the coefficient of x squared is 1, we do not divide by 2, but we take out 2, which is the coefficient of x squared. Remember, guys, this is an expression. We are not completing the square of an equation. We are completing the square of an expression. Two different things. Please, people, an expression has terms. There's no right-hand side. There's no equal to something on the other side, you know. This is an expression. Terms separated by a plus and a minus sign. So what we do is we take out the coefficient of the x squared term. We always do that. But when we take it out for the rest of the terms, it means 5x will be written over 2. And then negative 1 will also be written over 2. So we take out the coefficient of the x squared term. Please write that down. If we were saying what is the method, step number 1, take out coefficient of x squared term. That is step number 1. Why do we take out the coefficient of x squared term? It's because we want to ensure that our quadratic expression has the coefficient 1. All right? But if already it had the coefficient of 1, positive 1, then we wouldn't have to take out the coefficient of the x squared term. So that's step number 1. Take out the coefficient of x squared term. So coefficient is 1. That's the whole purpose and point. Remember, what we said yesterday is that we cannot complete the square of a quadratic expression unless its coefficient, the x squared term, is 1. Right? So we take out the coefficient of the x squared term, whatever it is. So if it was negative 2, we'd take out negative 2. If it was 3 over 2x squared, we would take out 3 over 2x squared. Then we check how it affects all the other terms. If we take out this 2 here, then inside we write an x squared. The next term is 5 over 2, because if you take this 2 and multiply back here, this 2 and this 2 cancels, we get back the positive 5x. If we take the 2 and multiply back to this negative half, it cancels this 2 and this 2, and we get back the negative 1. So by doing this, we are not changing the what? The quadratic expression, but rather we are setting it up so that it can be ready to be what? For us to complete the square. Step 2. Now that the quadratic expression has a coefficient for x squared of 1, we can do then the following. We add, after the x term, we add half the product of the coefficient of the x term. Half the product of the coefficient of the x term. Then we do what? We square it. But what we do as we add, we also subtract the very same thing. So we add it first. We add half the coefficient of the x term, which is 5 over 2. It's positive 5 over 2. So we add half of the coefficient, the product of the coefficient of the x term, and then we square it. Don't forget to square it. But we also subtract half of the very same coefficient of the x term, and we square it. All right? But we do this always after the x term. The x term. We do that immediately after the x term. We first start by adding half of the coefficient, whatever the coefficient of x is. All right? We half the product of the coefficient of the x term, and we square it, and then we subtract half the coefficient of the x term squared. Then remember, there was a negative half, which was the last term. Make sure that negative half is written at the very end, and then we close the bracket. Okay, right. So step number 2 on our notes, after taking out the coefficient of the x squared term, so the coefficient is 1. Step number 2 is what? We add half the product of the coefficient of the x term squared, but we add and subtract half the coefficient, half the product of the coefficient of the x term squared. Okay, this word coefficient, guys, it talks about the number before the variable. So the coefficient of x is 5 over 2, and it's positive 5 over 2. If this coefficient of x was negative, we'd multiply by negative 5 over 2. But since it's positive, we multiply by positive 5 over 2, and then we square it. But we don't only add half of that thing squared, we also subtract half of the coefficient of the x term squared, which we have done right there. Then obviously the minus half followed, so we write minus half. Okay. Step 3. The 2 is still outside. I'll leave it there. Then these first 3 terms in our trinomial form a trinomial, the first 3 terms, but it's a type of trinomial which we call a perfect square trinomial. So what we do is we continue x squared, we write it as it is. 5 over 2x, we write it as it is. There's a plus, so we say plus, and then we sort out what is in the brackets. What is 1 times 5? 1 times 5 is 5. What is 2 times 2? It is 4. And then we square it. Minus 5 over 4. Obviously, the other bracket will also be 5 over 4. And we square it. Minus a half. Okay. What we now have here, guys, for these first 3 terms inside the bracket. Just hold on, hang on. Okay, sorry about that. Just had to attend to something very quickly. Alright, so where was I? I was here. So, yeah, we had actually just added. So basically now we have this trinomial here, guys. These 1, 2, 3 terms. By adding half of the coefficient of x and then squaring it, this actually helps us to form from the first 3 terms what we refer to as a perfect square trinomial. And we spoke about this at length yesterday, that it helps us to form a perfect square trinomial. So we can factorize this perfect square trinomial. And what I then suggested yesterday was that you can actually take this expression and you can actually write it out. It's x squared plus 5 over 2x plus 25 over 16 if you actually apply the square to the 5 and the 4 as the numerator and the denominator value. Then you can factorize this. But then what I suggested yesterday is that to simplify life for ourselves, we know that this perfect square trinomial will form a binomial square bracket, right? And we can simply do the following. The square root of x squared will be the first term inside my bracket. Then obviously the 5 over 4, the square root of this entire thing. In fact, let's just say the 5 over 4 as it is. The 5 over 4 is a positive value. So we are going to write inside this bracket 5 over 4. And then we put a square on the outside. Now people, I'm sure if you were to take this, okay, and I'm just going to show you just very quickly. If I take that x plus 5 over 4 and square it like this, And then you know most that when you square this, it's like we are opening two brackets of x plus 5 over 4 and another one of x plus 5 over 4. If you multiply this out, you actually get x squared, because x times x is x squared. X times 5 over 4 is 5 over 4x. And then 5 over 4 times x is also another 5 over 4x. And then 5 over 4 times 5 over 4 will give you 25 over 16. In essence, you get this answer, x squared. Now this 5 over 4x plus 5 over 4x are like terms. And when the denominators are the same, what do? We add the denominator, the numerators, and then the denominator, obviously, since it's the same, we keep it like that. And this is 25 over 16. But remember, 10 over 4 can be simplified to 5 over 2x plus what? Plus 25 over 16. So this here, what you've gotten here, is in actual fact this trinomial expression. This 1, 2, 3 trinomial expression is a perfect square trinomial, and I said when we factorize it, we get x plus 5 over 4, the whole thing squared. How did I get this x? It's simply writing the square root of x squared here. How did I get 5 over 4 here? It's simply getting the square root of 5 over 4, the whole thing squared. So I write positive 5 over 4 in this bracket, and when I factorize this, it is actually x plus 5 over 4, the whole thing squared. So this is how I get my square bracket from the first 3 terms of the perfect square trinomial. But remember, there's this part now that is left, so I write it down, minus 5 over 4, the whole thing squared, minus a half. Right? Remember, that's the part that is left. Okay, I factorize the perfect square trinomial, but obviously there's these fractions that are left. So to continue to further simplify this, I then write 2 into x plus 5 over 4. I retain the square bracket for because the form, we are getting to the form. The form is nearly close to what we want. Then minus. This minus, remember, in board mass or bed mass, brackets are followed by exponents. So the negative sign must just stay for now. And then we must apply the exponent to the numerator and the denominator. 5 squared is 25. 4 squared is 16. When we remove the bracket, it's negative 25 over 16 minus a half. Now I can simply take my calculator, because what I want is the numerical value of negative 25 over 16. So I go to my calculator and I simply just go and type it in. Negative 25 over 16 minus 1 over 2 equal, my calculator gives me negative 33 over 16. So that makes life very easy. So I then continue and say negative 2 into x plus 5 over 4. The whole thing what? Squared. What did I get from my calculator? What is negative 25 minus 1 over 2? That gives me negative 33 over 16. So I go write negative 33 over 16. And I close that bracket. But now this 2 here, all right, needs to be redistributed back into the bracket, right? So in order to do that, I take this 2, I distribute it to the first bracket, but I cannot take this 2 and put it inside the binomial bracket because it's got a exponent. BEDMAS does not allow me to multiply something when there is clearly an exponent that has to be first considered before the number that is multiplied. So the 2, when we distribute the 2, we write 2 on the outside. The big bracket is removed. We just write the small bracket next to the 2, x plus 5 over 4, the whole thing squared. Then we take the 2 again, we distribute to the negative 33 over 16. What's 2 times negative 33 over 16? To make life easy, and maybe not to even crack your head too much, we just say 2 times, and then we say negative 33 over 16. Okay, that's 2 times negative 33 over 16. Right, we get an answer of what? Of negative 33 over 8. Okay, so we go ahead and we say negative 33 over 8. Okay, so I'll come back just now and highlight those steps. So sorry, that distribution of 2 helps me to remove the big bracket. Alright, so I'm just going to go back again and just regroup so that I can actually highlight the important steps. So let me go back again. So that is my answer, guys. I have completed the square of the expression. It's 2 into x plus 5 over 4. The whole thing squared minus 33 over 8. This has been the completing of the square of a quadratic expression. Okay, let me go back so that I can highlight the important steps. So now, what did I say first and foremost? When we look at a quadratic expression, how do we go about completing the square of the expression? So step number 1, if the quadratic expression has a coefficient that is not 1, we need to first get the coefficient of x squared to become positive 1. So how do we do that? We take out, step number 1, take out the coefficient of the given x squared term. So the coefficient of the given x squared term, what is a coefficient? It is the number next to the variable x. So the number is 2. So we need to take out 2. So this is what we do. We take out the 2, which leaves us with what inside the bracket? With x squared for the first term. Then for the second term, it leaves us with what? With 5 over 2. Because we took out 2, 2 does not go into 5 at all, because 2 does not go into 5. All right, it is not a factor of 5. 2 is not a factor of 5. So we write 5 over x as 5 over x over 2. Okay, then negative 1. 2 does not go into 1. So once again, we write the negative 1 over the number 2. So do you see this 5x over 2 and this minus 1 over 2? We write it over the denominator to this 2. Okay, so someone else may be asking, what if the coefficient of x squared was 3 and we took out 3? And we had maybe 3x squared plus 5x minus 1. That means for these denominators, we'd have the number 3. I hope you understand that. So that is the first step that is important, taking out the coefficient of the x squared term for all 3 terms in your quadratic expression, if the coefficient is not 1. Okay, now look at what is in the bracket. Do you see the coefficient of x squared now? It is 1. So that means I am now ready to do what? To complete the square of the expression. So how do I go about doing that? Step number 1. You must add half the product. When I say the product, it means I need to first say plus. Add means plus. I plus, then in brackets, half times the coefficient of the x term. Now you go to your expression. In the expression that is inside the bracket where the x squared term is 1, what is the coefficient of the x term? It is 5 over 2. Kaloku, this is where we start completing the square. So we're not focusing on the original one. We are focusing on this expression inside the bracket that has the coefficient of x squared, which is 1. That's where we start completing the square of the expression. So that means we can now do the following. Write x squared plus, we then add half the product of the coefficient of the x term, then we square the entire thing, and we subtract half times the coefficient of the x term, and we square everything. We do this addition and subtraction of all of this after the x term. we always do it after the x term. We don't do it after anything else. So that is why when you see this expression, what do you see? You're seeing x squared plus 5 over 2x. This is the x term. After that, what are we doing? We first add half the product. What is the coefficient of x? The coefficient of x is positive 5 over 2. So we half times the product is the product. We times it by 5 over 2, this coefficient, which is 5 over 2. Then we do what? We square it. So after adding this, we also subtract half the product of the coefficient of x, which is 5 over 2. So that is done. Add first, half times the product of the coefficient squared, then we subtract the same thing. Okay. If you are adding something and you're subtracting the same thing, what does that mean? If you add something and you subtract the very same thing, it means that all of that is gone. We are back to this expression. So we have not really changed the expression before this one here. All we've done is we've just added half the coefficient of the x term, the whole thing squared, and then subtracted it again. Then after that, we write the negative half, which was the last term in our quadratic expression. So that's negative half, and we close the bracket. So this is a major step, that after the x term, we need to add half the product of the coefficient of x and square it. Then we subtract half the product of the x term and we square it, and then we say minus half. We write this last term as it was there to begin with. This is grade 11. Okay, so this is an important step. Step number 2, add half the coefficient of the x term squared, and you subtract half the product of the coefficient of the x term squared. But we do this when? After the x term, like we have done here. We did this addition of the half of the product of the coefficient of x and subtracting half the product of the coefficient of x, the whole thing squared, after the x term. Let's move on. Step number 3, which is important. We write 2. The bracket is still open. We have x squared, which was there originally, plus 5 over 2x, which was there originally. Then we work out what is inside the bracket. Please, people, we work out what is inside the bracket while still keeping the square. Okay, so you can take your calculator quickly and say half times 5 over 2. What's half times 5 over 2? So I'm going to write this. Work out what is in your squared brackets. Work out what is in your squared brackets. All right, so let's work it out. What's half times 5 over 2? It's 5 over 4. Obviously, this 5 over 4 will also be a 5 over 4 for the other square bracket. Are we together, people? I just want to get an indication that we are all moving, we are understanding. So far, so good. These important steps that Gift was saying I need to sort of like, emphasize. Okay, so we work out what is in the square brackets without removing the square. So 5 over 4 is the answer we get inside this square bracket. 5 over 4 is what we get for this square bracket. Okay, and it's followed by minus half. Step number 4. The first 3 terms form a perfect square trinomial, which we can factorize. I repeat, the first 3 terms, after you have worked out what is in each square bracket, the first 3 terms form a perfect square trinomial which we can factorize. So So let's go back here. We have x squared, the 2 is written there. Inside the bracket, we have x squared plus 5 over 2x plus brackets 5 over 4 raised to the power 2. These first three terms form a what? A perfect square trinomial. We can factorize this perfect square trinomial so that can help us to form our square bracket, which is important for the form that we need to get this quadratic expression into. All right. So x squared plus 5 over 2x plus 5 over 4 to the power 2. This is a perfect square trinomial. How do we factorize it? The shortcut that I said to you yesterday that quickly helps us to factorize this thing without really thinking too much is we simply take this x, write it as your first term in your bracket. Simply take this 5 over 2 with its sign. So the 5 over 4 here, sorry, the 5 over 4, not the 5 over 2. Simply take the 5 over 4 inside this bracket. It is positive. So you take this 5 over 4, you write plus, because the 5 over 4 is positive. You say x plus 5 over 4. You close the bracket and you square it. People, this is something that is unique about perfect square trinomials. Perfect square trinomials can be factorized simply by, when we know what the first term, the x squared term is, and when we know what the base of the last term is, then we can basically represent those two together inside the square bracket. That is our factorization of this perfect square trinomial. So that's why I'm saying the first three terms form a perfect square trinomial which we can factorize, right? And this factorization is very quick and to the point. Remember, what we write here is a representation of what these first three terms are, the perfect square trinomial factorized. Are we together? So these are the first three terms factorized. This is what it is. Then what are we left with? Minus 5 over 4, the whole thing squared, minus 1 over 2. So 5 squared will give us 25. Okay, so we write minus 5 over 4, the whole thing squared, minus a half. Right? And then we still retain and close that bracket. As we conclude the problem, remember the 2 was outside for all terms in the bracket. Okay, yeah. And inside the bracket, currently, if we subtract minus 5 over 4, the whole thing squared, with minus a half, okay, this minus 5 over 4 squared gives us negative 25 over 16, and then followed by minus a half. If we take our calculator and say minus 25 over 16 minus a half, what do we get? We get negative 33 over 16. This then helps us to see that inside this bracket we have how many terms? We have this first square term minus a constant term. But we need to remove the big bracket. Okay? We need to remove the big bracket. Okay? And in order to remove the big bracket, I'll answer you just now, gorgeous, because that's a very critical question that you've asked. We need to remove the big bracket, right? So in order to remove the big bracket, we need to distribute the 2 inside to the x squared term, and then distribute the 2 to the constant negative 33 over 16. So when we distribute that, 2 times this x plus 5 over 4, the whole thing squared, will give us 2 brackets x plus 5 over 4 squared. Then we take this 2, we distribute it by multiplication to minus 33 over 16. So what is 2 times negative 33 over 16? You take your calculator, positive times a negative will give you a negative, and then what's 2 times 33 over 16? It will give you negative 33 over 8. This is our quadratic expression in the form whereby we have completed the square of this quadratic expression. Okay. Now, Gorgeous asked a very important question. And the question that Gorgeous asked is, how do you know that it is a perfect square trinomial? Okay, now for that purpose, unless there are any other questions, I'm going to answer that question, Gorgeous. A very good question, Gorgeous A. Anyone with any other questions as far as this method is concerned? I've highlighted the important steps here. Okay, so step number 4, as you will have noted, is the first 3 terms, they form a perfect square trinomial which we can factorize. Okay, after factorizing, all right, after we have factorized, then we should then be able to sort out our bracket first and then our constant term. So I'm just going to write it generally. Our bracket first and our constant term. And remember, as the situation stands, whenever we had to take out a certain number, there's that number that is waiting to be distributed back, which is 2. So after we have sorted out our square term and sorted out our Q value, because remember our Q value is sorted out by adding the fractions. Okay, so we need to, the first 3 terms form a perfect square trinomial which we can factorize, and we can simplify to get Q, right? Obviously to get Q we can simplify, and it's only just simple simplification and addition of fractions that we take care of there to get this negative 33/16. Our last step is that we need to distribute the factor that we took out. We need to distribute the factor that we took out inside the 2 terms again. Okay. And forgive my handsome handwriting. We need to distribute the factor that we took out inside the 2 terms. Remember, we had taken out 2. What we do is we distribute that 2 to the square bracket. But remember that 2 stays outside because this square does not allow 2 to go in. Because bad math says brackets then exponents. Multiplication comes later. So we have to keep the 2 outside the bracket, squared. Then we take the 2 we distributed to the fraction negative 33/16. 2 times negative 33/16 gives us negative 33/8. So this is our expression, quadratic expression. We have completed the square of that original quadratic expression by following these steps that I have just discussed. Now, I need to ask, are there any other questions besides Gorgeous's question so that I can answer that question and also maybe get any other follow-up questions that people may have? Any questions about this method? Any questions? Any other question that is arising about how we complete the square of a quadratic expression? This is grade 11. Okay, so that means I need to go to Gorgeous's question. Gorgeous asked a question: how do you know that it is a perfect square trinomial? How do you know that it is a perfect square trinomial? I want to actually answer that question by looking at a binomial squared. I want us to just explore this thing, right? Now x plus 1, the whole thing squared, is a perfect square binomial which leads to a perfect square trinomial, right? Remember, to get the perfect square trinomial, take note, you apply FOIL, you multiply the x and the x, you get x squared. You multiply the x and the 1, you get another x. You multiply the 1 and the x, you get another x. And then you multiply 1 and 1, you get a 1. What do you see? You get x squared plus 2x plus 1. Okay? So this here, x squared plus 2x plus 1, is what we refer to as a perfect square trinomial. All right? And what I have said to you guys is that if you want to factorize a perfect square trinomial, all right, remember x squared can be written as x squared, 1 can be written as 1 squared, you know. And what I'm saying to you guys is that if you want to factorize this thing, instead of really thinking too much, because you know that this is a perfect square trinomial, you take this x, you take this one, all right, without the squared and the squared, and then all you do is you square it at the top. We can do this because we know that this is a perfect square trinomial. Now, what I am saying to you, and you need to listen to me very well when I say this to you, when you do this thing of after the x term, remember when you took out the 2, you were left with x squared plus 5x over 2 minus half. What is important for you to know as a grade 11 learner is that when you are completing the square of a specific quadratic trinomial, when you get to this step where you add half the coefficient of the middle term, which is 5 over 2, and you square it, the minute you do that, you are setting up these first 3 terms to become a perfect square trinomial. You are forcing a situation where you're making x squared plus 5x over 2 to become a perfect square trinomial. Why? Because you're adding half of the coefficient of x, which is half times 5 over 2. And then what are you doing after that? You are squaring it. So look at this trinomial. It's x squared plus 5 over 2x plus 5 over 4. Okay? Yeah. So that's what's important here. That's what's important here. All right? Is that this is a perfect square trinomial. And the way that you can easily factorize it is you take this x, you take the 5 over 4, and then you simply take the x as it is. You take the 5 over 4, whatever the sign was. If it was minus 5 over 4, we'd have written minus 5 over 4. If what is in the bracket is minus 5 over 4, we'd have written x minus 5 over 4. But because what is in the bracket is positive 5 over 4, we write x plus 5 over 4. So for the purpose of completing the square of a trinomial, adding half of the coefficient of the middle term always leads us to a perfect square trinomial. It always is a perfect square trinomial, but we need to ensure that we first add half of the coefficient and then we subtract half of the same coefficient and we square it. I hope that makes sense. So this part, the first 3 terms, will always form what we refer to as a perfect square trinomial. And a perfect square trinomial can be written as a binomial squared. Okay. Okay. This, I repeat again, is a what? Is a quadratic expression. Okay. It's a quadratic expression. Yeah. Here we are not being asked to solve for x by completing the square. Here we are asked to complete the square of an expression so that we can find the maximum and or the minimum value. All right. I think some of you are confusing because for instance, I see someone. Yes. Gorgeous. I hope we are together. Yeah. So that addition of half the coefficient of the x term will always lead you to forming for the first 3 terms a perfect square trinomial. That is the whole purpose of the completing the square method, because remember, what are we actually looking to do by using the completing the square method? We want to basically change a quadratic expression of this form to become a quadratic expression of this form. How in the world are we going to have a binomial squared term? We are going to have that if we are able to manipulate this quadratic expression in this way, whereby we take out the 2, we have an x squared term, and then when we have this x squared term followed by its x term, what we do to it is we add half the coefficient of the x term and we square it, and then we subtract the same thing. All right. so that the first three terms can form a perfect square trinomial so that we can get the binomial squared bracket, which we are looking for. We want to get it to this point. Are you with me? Right? So I hope you guys are, like this thing, it's coming. Kancane, kancane, you know. I once heard some learners saying, kancane, 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 sizophumelela. Hayi, kancane, 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 people, hanyane, hanyane, some people say. So you just take it, like I said, one step at a time, but that is the whole objective. You remember when I taught quadratic expression, changing the quadratic expression in standard form to this form. There's no way we can get it to this form if we cannot formulate this perfect square trinomial, which will lead us to a binomial squared. And then obviously this Q value, where will it come from? It will come from you continuing to say half. And when you've added the half, the coefficient squared, you must also subtract half the coefficient squared and then write the constant term at the end, so that these last two terms can be able to help you to formulate the Q value, which is in this case negative 33 over 8. Are you with me? Yeah. So please, people, man, yeah, and we distribute the 2 back so that we don't think it's negative 33 over 16, because remember the bracket was over everything. So when we take the 2, we multiply it with the x squared bracket. There it is. Okay, there's our the square bracket. Then we take the 2, we multiply it with the negative 33 over 16, we get negative 33 over 8. Okay, yeah. What Wilmore is talking about, Yena, is talking about when we are asked to solve for x by completing the square. We have not looked at that yet. But if you are someone who has already been preparing for your grade 11 syllabus and you've been studying, you are already there solving for x by completing the square. We have not gotten there yet. Solving for x by completing the square method has a particular approach, but it applies to equations. What we were looking at is not an equation, it is an expression. Hey people, I need you guys to understand there's a difference between, guys, x squared plus 6x, this is an expression, but x squared plus 6x is equal to 0. This is an equation. You cannot solve an expression. You can't solve for x for an expression, but you can solve for x for an equation. So x squared plus 6x, we complete the square of an expression, and we use the method that I've just explained. But when we are solving for x, there are many methods that we can apply when we are solving for x. All right? And this is the next section that we are jumping into after. I am very confident. I need to first be confident that you guys understand how do we go about completing the square of a quadratic expression. The goal or the objective of completing the square of a quadratic expression is to change a quadratic expression of this form to this form. That is the goal and the objective of completing the square of a quadratic expression. I repeat, expression. Okay, so Oratile, you've answered the Wilmore very well in the comment section there. I appreciate your comment. And then Gorgeous, I hope you have captured the essence of us formulating that, yeah, like I said, that perfect square trinomial for the purpose of writing the expression in the form that we need. Okay. I think let me do one last one, and depending on if people get it, then I guess that will be it. Let's do one last one. So this one, let's look at it. It's negative 1 over 3x squared plus x minus 2. Step number 1. What did step number 1 say? We need to first do what? Let me see if you guys can lead me and maybe comment in the comment section. Step number 1, what do we do? This is an expression, it's a quadratic expression. We need to complete the square of this quadratic expression. So step number 1, Step number 1. Okay, not necessarily, Kanye. I want us to be specific. Getting rid of the negative sign, that's not step number 1. So I would actually like take you to court for that one. I'd fight with you a little bit there. Abu, very good. Step number 1, we need to take out, guys, this is an expression, so we need to take out the coefficient of x squared, which is negative 1 over 3. Take him out. So what are we left with inside the bracket if we take out negative 1 over 3? For the first term, what are we left with? For the first term, if we take out negative 1 over 3, we are left with what? For the first term, we are left with, as our first term, we are left with, thank you, we are x squared. For our second term, if we take out a negative, but we want a positive x, what is our second term? Let's see if these people know their stuff. Now you see the people that know their algebra and they don't. If we take out negative 1 over 3, we want positive x. Negative 1 over 3 times what will give me 1? Positive 1. Very good. I love it, Gift. I love it for you, Gift. So Gift is spot on and precious. At least the number, you are spot on. So it's negative 3, but it's negative 3 what? X. Okay? Negative 3x. Blade boy, if you're saying negative x over 3, think about what you've just said. Remember, we took out negative 3, negative 1 over 3. Now we're saying negative x over 3. If you times those two together, what do you get? Do you see numerator and numerator? We get negative times the negative is positive. 1 times x is x. 3 times 3 in the denominator is 9. Do we get that back? No, we don't, guys. Do you see? So very careful. So it's negative 3. All right, no problem. It's no problem. We make those. They are allowed. Whilst we are still learning, guys, making mistakes is probably one of the best things you can do because you learn from them. Once you've learned the lesson, please don't repeat it. Okay, so yes, it's negative 3x. Spot on. Then our last term, negative 1 over 3 times what will give me a negative 2. Sometimes they say you just say negative 2 divided by negative 1 over 3. That should give you the answer, right? So what is it? Negative 1 over